being able to factor it and get it all the way down to finding all of our real roots. We're going to be able to take large polynomials and factor them by the end of this chapter and be able to graph them properly. So we're starting on working our way towards that here with looking at our zeros and finding our roots and zeros. So it starts with this fundamental theorem of algebra, which is wordy. That's if a polynomial has positive degree and complex coefficients, meaning we've got numbers there, then we have at least one root. It might be real or it might not be real, but every function has at least something we can call a root. That's what it's saying here, is that if we have a polynomial, there is something we can solve for. The second one, our factorization theorem, says that if we have a polynomial of degree n, meaning it has some sort of positive degree, it could be a degree of 1, could be a degree of 3, could be a degree of 20, then we will have n roots. So if I have a degree of 2, we will have 2 roots. If I have a degree of 4, we will have 4 roots. If I have a degree of 5, we will have 5 roots. They may be imaginary, they may be repeated, but we have roots that are the same number as our degree. Not more. I cannot have more roots than my degree. So a polynomial of degree n has n complex roots. I gotta change that wording, so I don't like that. So a polynomial of degree n has n complex roots. They don't have to be different. Because if I have x to the third as my function, I have a triple root at 0. So they don't have to be different, but I have 3 roots. And we're going to be working with this to start finding exact equations and finding these more specific polynomial equations than we've worked with before. So we're not going to be doing as much estimating or things like that. We're going to start working on getting properly accurate equations, which is going to lead us to getting properly accurate graphs. Not necessarily sketches, but graphs. I know there's a lot of words up here, so I'm going to give you guys some time to write this. Okay. I'm starting to see the writing slow down. So take like 10 more seconds. All right, I'm going to change this in 3, 2, 1. Because Because we have one more word to have up here. It's called multiplicity, which you may have heard before. If you did honors, I believe they talk multiplicity. If you did regular algebra 2, we don't usually talk multiplicity. And all multiplicity is how many times the factor occurs. Like if it is x minus 2 quantity squared, that happens twice in that function. That root occurs at that number of times. So the multiplicity is going to be the power on that particular factor. Ooh, I definitely adjusted the formatting on this one and it didn't pull that version. Must have imported it before I did that. Okay, so what we have at the bottom is I have, excuse me, 3 examples or 3 systems that we're going to use to do this. And we're going to practice this. We're going to look at multiplicity and what we mean by that. So on this first one, there's really not anything different about it. We've got some zeros here where we're going to write these into, it's going to blink, there we go. We're going to write this into factored form. And we're going to see what we can get here. So, if I have zeros of 2, 4, and -1, how are we going to write factors for that? X minus 2. X minus 4. Oop, I have to actually put that in there. And X plus 1. Oop, sorry. Not going to page out. So when we're looking at our proper standard form here, what we just wrote on our other page, we have this as our function rule here. And then we also have an a value that's typically out front. We didn't give you the information about the a value, so right now we're just going to put the letter a. It could have a stretch, compress, something like that. We could have a constant out front. So for right now, we're just going to put an a in here. So this is what we've done other times before. This piece right here has what degree? 3. So we wound up with exactly what we should have here, which is a degree of 3. So that's not any different. Each of these factors here has a multiplicity of 1. Each of these factors occurs 1 time in our function. By default, factors have a multiplicity of 1, that they happen once. If it does not have a multiplicity of 1, we will tell you what that is. So when we look at B, I've got my zeros of 3 and 1 that have a multiplicity of 1, and 0 that has a multiplicity of 2. So when we're coming to put this into our function, our f of x, we still don't have our a value here, so I'm still just going to put a letter a. How am I going to write the factors for 3 and for 1? X minus 1 and x minus 3. They have a multiplicity of 1. They're just regular factors. They look just like this. When we have a multiplicity of 2, that means I need that to happen twice. And you can either think of it as x minus 0 times x minus 0 and do it twice that way. Totally fine, 100% valid. You could do it as x minus 0, the quantity, and square it. That is also fine. Either way, it's going to simplify down to be x squared. that has a root of 0 and happens twice, our multiplicity of 2. So, just to double check right here, what degree does this f of x have? 4. So we got as many pieces as we need here. So this degree kind of works as a little built-in check for us if we look back and make sure we have the right number of roots. So we did get to a degree 4 here. We did get to a degree 3 here. This bottom one, I'm actually going to give us a little bit more space on. So I'm going to change the view here, just so it's easier to see, because it was way at the bottom and had very little space. So we've got zeros at 2 with a multiplicity of 1, 1 with a multiplicity of 2, and at 3i. We're supposed to get a degree of 5. So we're going to start with the pieces we see. So I'm going to take my f of x. We still don't have anything about a, so I'm just going to leave that as an a right here. How do I write my root of 2 with multiplicity of 1? X minus 2. How do I write my root at 1 that has a multiplicity of 2? Yeah, so we can take our factor, that x minus 1, and square it. Totally a thing. Then we have this 3i thing. And the thing with imaginary roots is they never happen individually. They never happen on their own. It is always, 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 every time going to be plus and minus. Every single time. Imaginary roots cannot happen in singularity. They can't. They always happen in pairs like that. So we're going to have positive 3i and negative 3i. So how could I write those as factors? What did we do when we had like a 1 or a 2? X minus 3i. We can do it that way. And then we can do x plus 3i. But we're not used to seeing polynomials that have i's in them. Ew. So let's multiply these together and see if we can get rid of those i's. Because if I multiply these chunks together, what are we going to get? X squared. Yeah. So because our 3i times x minus 3i times x, those guys cancel out. So we're going to have our minus 9i squared. What does I squared equal again? Negative 1. So this is the same thing as x squared minus 9 times negative 1. So it's the same thing as x squared plus 9. So our function, our f of x, when we're writing it, we can have this as our x minus 2, x minus 1 squared, and x squared minus, or x squared plus 9. So we're not going to leave i's in our function rule, because that makes it really hard for us to figure out things like y-intercepts, the constant that's at the end, seeing what our end behavior is going to do, all that jazz. So we know that this has 2 real roots and 2 imaginary roots. Imaginary roots always happen in pairs, every single time. So then let's check and see if we got the degree we needed to have here. What is the degree of f of x here? 5, because I have 1x here 2 x's here, and 2 x's here. So 2, 4, 5. So we did wind up at our degree 5. Okay. Questions on that bit? So it's just a little weird with the I thing. It's a little weird. Okay. I'm going to bring it out to our full page. Any questions on this section here, this page? Okay. So, ooh, hello screen. Can we get all the words, please? Thank you. Please. Why won't you do anything? I love that so much. There we go. We'll use that picture. All right, so we're going to do A and B. I had them separated onto separate pages, but then the screen decided to be a jerk. Oh, it's going to do that thing again. Boop, there we go. Okay. So we are asked to write a polynomial in standard form. So we're going to fully multiply it out. And we're going to find our A value here. So I know zeros are 4, 1, and -3. And we're given a little bit more information. So we're going to start with our zeros and write our basic form polynomial like we just did on the last few. So we're going to start with our f of x equals a times, what are our factors? X minus 4 and x minus 1 and x plus 3. So just like we did on the last ones, taking our zeros here. We didn't have any multiplicity listed, so we're assuming that their multiplicity is 1. If nothing is said, you can assume it's 1. Questions on the building of the standard part there? Because now what we're going to do is we're actually going to find the A value. And the way we do that is we actually use this other piece of information we're given. So we know f of 6 is 180. So how could I use that to help me figure out what A is? 6 is going to substitute in for what? X. So this is my x, and this will substitute in place of the f of x. So we're going to set this up as 180 equals our A, and we're going to take that 6 for our x. So it's 6 minus 4 and 6 minus 1 and 6 plus 3. So we're going to simplify this. I'm going to have my 180 equals A times 6 minus 4. We get 2. 6 minus 1 is 5. And 6 plus 3, 9. So we have A times 2 times 5 times 9. Should not be 98. 98. Oh, 98. Thank you. Yes. It just got smushed together and my brain went 98. I'm like, So we have 90A equals 180. So what does A equal? 2. So we found that A value. So I'm going to come up here to my function, and I'm going to put that A value in to get my f of x. So we're going to have f of x equals 2. So now I know that A. X minus 4, x minus 1, and x plus 3. Are we done? To get it in standard form, what do we need to do? Multiply it out. The whole thing. No parentheses left. So do it in batches, in chunks. I'll take these two pieces and these two pieces. And I'm just going to multiply them in pieces. So we'll have our 2x minus 8 as one piece. And we'll have our x minus 1 times x plus 3, giving us x squared. 3x minus 1x gives us plus 2x minus 3. Then we're going to multiply the whole thing out again. And this time I'm going to not combine terms at the same time because there's just too many pieces. So we're going to have our 2x cubed plus 4x squared minus 6x minus 8x squared minus 16x plus 24. Does everyone see where I got those from? So let's combine our like terms. Our f of x is going to be what? 2x cubed minus 4x squared. Plus 24. This is our answer. So just from the list of roots and 1 point, I got all the way to a standard form equation. A specific equation. Okay? We're going to do the same thing with part B here. We're given zeros. I've given an example point, and we're going to do that again. So I'm going to give myself a little bit more room on the page. I'm going to turn to view. Just so that we have a little more space and I'm not writing at the very bottom, especially for those of us in the back. All right. So let's look at B here. Oop, that's not a pen. How are we going to start this? A. Yep. Gorgeous. X minus 2 and x minus 4. Does everyone see where those pieces came from? Awesome. Just checking in. Because Reese is rocking it. Absolutely rocking it. I'm just making sure other people know where we're headed to. Okay, so now we need to find our A value. And this is a little less pleasant, but we can do it. Because what is the x that we know? X equals 1/2. We can do that. F of 1/2 equals 63. So I know it's going to equal 63, and we're going to just substitute it in our 1/2. So we're going to have our 63 equals A. And we can do this simplification here. We have 1/2 plus 1. What is 1/2 plus 1? 1.5 or 3/2. I like to do improper fractions simply because we're multiplying them all together. It's easier to do when they're improper fractions. So my plain x, that one's just going to be our 1/2 again. That's this guy here. How about 1/2 minus 2? -3/2. And how about 1/2 minus 4? So 4 is the same thing as 8/2. So 1/2 minus 8/2 is -7/2. So multiplying fractions, multiply our numerators, multiply our denominators. Yeah. So we wind up with 3 times 1 times -3 times -7, which is the same thing as -7 times -9, which is 63. 2 times 2 times 2 times 2 is 16. So what is our A going to equal? 16. Because to get A by itself, what do we need to do? So you can do this in 2 steps if we've forgotten what we do. So multiply by 16 on both sides. That guy cancels out. I'm going to leave it as a product here for a second. 16 times 63 equals A times 63. Divide both sides by the 63. So if you do it in 2 steps, that's fine. We still wind up at 16 equals A. You can also remember that we're going to multiply by our reciprocal. So 63 times 16 over 63, and the 63s are canceled out. We still wind up at 16. So whether you do it in 1 step or 2, it does not matter. We need to make sure we wound up at that A of 16. Because again, we need to put this in standard form. So I'm going to take this guy and put in my A of 16. So we're going to have our f of x equals that 16 times x plus 1 times x minus 2 times x minus 4. And again, we're going to multiply this out. We need to put this in standard form. So I'm going to multiply this in chunks. I'm going to do this as 1 chunk. And I'm going to do this as 1 chunk. You can think of that as 16x times x plus 1. Or you can do it in 2 sets of distribution. But either way, we should wind up here with 16x squared plus 16x. And the right-hand piece is going to be our x squared minus 2x minus 4x, giving us minus 6x plus 8. And then, yes, we are really multiplying everything out. I give myself a little bit more space here. Because we're going to have our 16x squared times our x squared, giving us 16x to the 4th. Then we're going to have our 16x squared times our minus 6x, and we get minus 96x cubed. 16x squared times 8 gives us 128x squared. Then we're going to have our 16x times the x squared to get our 16x cubed. 16x times the minus 6x, we get minus 96x squared. And our 16x times 8 gives us 128x. When we have trinomials being multiplied by anything, I do recommend not trying to combine your like terms in your head at the same time as multiplying. I recommend writing it out just because that is too many pieces, and trying to find the pieces that match up is really challenging to do it in your head. But now we're going to combine our like terms to get our final answer for our f of x. So what is our function rule here? 16 what? X what? X to the fourth minus 80x cubed. Forgot the 0. There we go. Plus our 32x squared. And 128x. Questions on either of these at any place, point, time, anything? Feeling okay on this? Okay. So now we're going to use that little half sheet. Because now instead of me telling you what our zeros are, we're going to find them. We're going to construct our polynomial in factored form, including the a values. We don't have to multiply it out in the standard form, but we do need to find the a. Okay, I'm actually gonna cover up the right one so I can use this space to write and not have to write below. I'll put the right one up on the next slide so that I could just not have to write teeny tiny at the bottom. So you guys can glue that in your notebook or write on a separate page next to it or whatever you need to do. I'm just giving my space a little space to write. So let's find the pieces that we need. Where do we have roots? And 3. What degree are we going to wind up at? Look at our end behavior here. Should we wind up even or odd? Evens. We need to make sure we wind up at even. Which one of our roots is going to be a little weird? The -1. Why? It's got a multiplicity of what? Of 2. Because it's a bounce root. That's how we know it's a multiplicity. It's bouncing back off my x-axis. So when we're putting this together in our factored form, we have our f of x equals, we do not know our a at this point. What do we have? Plus 4. X plus 1 squared. And x minus 3. What can we do to figure out what our a is? Yeah, look, we were given a point. 1 negative 8. So how do I put that into my equation? X is equal to 1. Where's the negative 8 go? in place of f of x. F of x is y. So negative 8 goes in place of our f of x. So then we're going to have our a, and we use our 1. So we're going to have 1 plus 4. 1 plus 1 squared, and 1 minus 3. Substituting in that 1. So we have our negative 8 equals a times 1 plus 4 is 5. 1 plus 1, that's 2. 2 squared is 4. And 1 minus 3 is negative 2. So we have a times 5 times 4 times negative 2. So negative 8 equals a times negative 40. So what is our a going to be? What do I do to get rid of the negative 40? Not add it. Divide it. So negative 8 over negative 40. It is definitely also not 5. 1/5. So our equation of f of x is our 1/5, and then all of our expression at the top. X plus 4, x plus 1 squared, and x minus 3. We were asked to write it in factored form, so we do not need to write it to multiply it out. Because it says up here, factored form. Same vibe on the next one. I'm just coloring that so I can see. Questions on this one? Let's do this one then. Where are our roots? Negative 3, negative 1, 0, and 2. Do any of them have a bounce on them? Do we have any double roots? 0 is a double root. So this one has a multiplicity of 2. So write this one out. Get yourself into your factored form and see if we can figure out what our a is. We've done the a thing a whole bunch of times. See what you can come up with. Just because honestly, it's probably faster if you guys do it independently than for me to talk it through. See if you guys can find your a. Anybody get to an A? 1. Our A is 1, which means our final f of x form is exactly what we would write for factored form normally. We will keep working with section 4.3 tomorrow. It even still has the 4.2 homework up here. I don't even have the 4.3 homework up there. As a reminder, PSAT Thursday, quiz Friday. Have a great rest of your day. See you tomorrow. Bye.